After a very impressive career in corporate medicine, my wife decided to change tracks, so she asked me to build her a Zome. We had been big fans of Johnny's work at Trillium Domes, and so we bought his 20-foot Zome plans, and I began leveling out the build site over here by the creek in our oak forest. Once I had the ground roughly leveled, I determined the center of where the space would be, and then drove a copper pipe into the ground that would serve as not only the centering reference for the rest of the building, but also a ground for the eventual earthen floor. So I described the radius and excavated my rubble trench, and then went over to the cheese cave where I had some leftover drain tile pipe from that build. And we got that over to the Zome site and dropped it into the trench. Then I dug a gravel pit for any drainage from that drain pipe to perk into the ground. Once I had that installed, I backfilled with 3/4 basalt gravel, which actually should have some insulative effect, isolating the thermal mass underneath the building. Then I flattened all that out with a rake and got out the laser level and checked my elevation all the way around. And once I was satisfied with that, I tamped that gravel and started working on the forms for the concrete pour. I'm calling this a bikini bond beam because it's just 3.5 inches high and 3.5 inches wide, and that's sufficient to carry this Zome and only required 10 bags of concrete to fill. So it's very economical and embedded energy footprint and labor. This shape is a decagon, so it's a 10-sided polygon, and I established the inside dimension like so, and then I just measured my spans, my diameters, and my radiuses from edges and corners and staked it at that location. Then I went through the laser level and I put a mark on every stake at the same elevation so I could just lift the form to that mark and attach it and get level all the way across. And then the longer outside form boards I assembled. And it looked like that. Once I had the elevation established on the outside as well, I put these spanner boards to keep a consistent width and checked everything again with a laser level before I poured. I've had problems with cows stepping on forms or elk or bear moving through this little forest, so I just want to make sure that everything is just right before I set it in stone. As I shoveled the concrete into this form, I would lift the rebar into place. It's just a single course of 1/2-inch rebar, all tied together. And then did a surfacing on top of this. Once it is set up for 3 days, I stripped the forms off. Now the outside forms are long enough to recut and use as the sill plate that will go on top of the bond beam. But the inside forms were too short to reuse for anything in the project, but I did have a plan for those as well. To get the inside form removed, I cut through with my multi-tool, and when I got close to the concrete, I just gave myself a little space with this pry bar, and I was able to finish the cut enough to use a little brute force and get everything freed up from the concrete. And that's what our finished bond beam looks like. I backfilled a little bit. I had a low side on the grade here. And then I excavated for a sandbox. I'm always using sand for lots of plaster and other projects around the farm. And as a kid, I always wanted a really deep sandbox, so I thought I could make something for the children that come around. And reuse those inside forms as walls for this sandbox enclosure. Once I had 4 of these panels, I attached them together and then shoveled a 1.5 tons of mason sand into the pit. So underneath the earthen floor of this building, I put a 6mm vapor barrier and attached those 2 pieces of plastic with Gorilla Tape. And then it's just a matter of backfilling this with about 4 inches of road base. So road base is clay, sand, and gravel. And filled that, got everything leveled off. And of course, there was a lot more shoveling to be done. But once I got the whole thing filled, I took a 3-inch screw and screwed it into the bottom of this 12-foot 2x6, dropped that screw into my center pipe, and used the top of the bond beam to screed along and get a uniform, flat surface on this entire area. Then I went down to the rental yard and got a vibrating plate compactor and went around about 4 passes over this entire surface just to establish a stable, firm underlayment for the earthen floor that will follow. With that complete, it was time to start building our sill plate and pony wall. That goes here and has that 24.5 degree pitch to the outside. So that first triangle, that first layer, tips out. So I took the angle on the miter saw and then set the table saw blade to it and ripped the top bevel on all of these pony wall boards. Then attached those to the sill plates with Stefano's help. And when we had all those assembled, we took them over to the Zome site and attached them together and then re-pulled all of those radial dimensions. Once we had it in exactly the right place, I ram set it and then anchored it with concrete anchors. Now the building of the Zome is a lot of production, and so I've got a big stack of these 12-foot 2x6s, and all of the dimensions of the panels are under 4 feet. So take all of these and chop them down to 4 feet and pile them up. By using 2x6s instead of 2x4s, we get much straighter, higher quality lumber. So we take our 2x6s and cut them down to 4 feet and then rip all of them in half. So I've set the fence on the table saw at exactly half, and that way I'm able to reproduce identical strut material. Once all those are cut, it's a matter of cutting the appropriate angle for each of the parallelograms on each course of this zone and determining the exact length and setting a fence on the miter saw, and then I can just repeat the cuts. So basically you set the saw up once and you can do an entire course of 9 or 10 panels, each with 4 struts. The entire fabrication of all the panels took less than a week. Then once I have my 4 strut legs, I set them on top of the first panel, which I've got anchored with a spanner board at the appropriate center width. And then I pre-drill all of the holes and use 3-inch construction screws to tie everything together. If I were to do this again, I would then attach the panel at this point so that I keep that center span absolutely correct without having to worry about it. So it's a matter of working from our stock of struts, cutting our angles and links, building panels, and stacking them up. Those two chicken tractors in the background have 80 Cornish cross chickens in them, which is our year's supply of chicken. On some of the steeper cuts, a 45-degree secondary fence is required to get past the 50-degree limitations of my saw. So I'm making the bottom panels, the Z 4.5 from the Trillium Domes plan, and I'm just trying to determine the best workflow. So we have to make 9 of these. This will be 2, so I need 7 more. I've already cut the long bases with the 53 and whatever angle on them, and I've got that jig set up on the saw now, and I've got those cuts again on all of the struts that are going to form the rest of these panels. So I'm thinking, because that jig is set up and it's not as simple, we'll go ahead and pull all those angles on a bunch of the strut stock on that table over there, and then I can come back and cut the other. See, these two pieces, this one and this one, are different lengths, so that you can keep the reciprocal framing pattern. So we butt 2 there and lap past there, and vice versa on the other side. So I'm thinking we'll cut all the steep angles now, and then just do 2 runs, 2 settings on the chop saw for the other legs. One of the great things about the Zome plan is that you could assemble all of these panels at one location and then transport them all to a remote location in a couple of pickup trucks or one 18-foot trailer. And then if you can put together a crew of 3 to 5, you could assemble the entire thing in a single day. Now, compared to something like a yurt, this Zome is certainly a more durable alternative. It, of course, requires a little bit more carpentry skill than assembling a yurt, but the total material cost for this build was right around $5,000, even with all the plexiglass that's involved later on. We're laying out for panel Z2, and what we've realized is that we can get one full one and then another one that laps on to the next panel. But if we transfer this geometry over to that corner of that panel, we can just stack these up and rip 4 at a time. So we're going to do that. Here's our setup. We have 4 sheets. We have our layout panel on top. We're clamped here. We've got a couple of stringer boards underneath that'll keep these from flopping down as we cut them. So now we're just going to take the worm drive and cut them out. How about it?
How about that?
Here's the jig that I've come up with to cut the 60-degree miters for the Z1 panels. Basically have these boards attached with a 45 that's consistent through both. And then I attached this piece of lumber to the bottom of that. Unfortunately, it is not, for some reason, in perfect plane with the table, so I've got a little shim clamped on there. So with this at a 45, I set the miter gauge on the table saw of 15, and that gets me 60 when I make this cut. And to get the length, I take my template piece, line everything up there. That's going to be my cut because of the jig and the way it's all set up. I can't get to that cut in here, so I will clip it off with the circular saw there so that I can get in there. Down, 37 to go. To get these Z1 panels assembled with 3-inch screws, I had to be very careful about the angle that the screw entered the wood so I could grab enough of the wood behind it to make a good joint. And so I'm eyeballing with the screw on my pilot holes. These Z1 panels are the trickiest in the build because of the steep angles, and then these all got plexiglass, which caused me some trouble, and I'll get into the details on that in a minute. So you can see the angle that the screw has to take to get a good grab on both boards here. Then, once I had the panels assembled, I took the plexiglass, stacked it all up, and I was able to get 2 of the Z1 panels sheathed with this plexiglass out of 1 sheet with enough scrap material at the bottom to make the windows. This plexiglass gave me absolute fits. I'm using a cordless Milwaukee saw here to cut it with that new blade, but basically just welded the acrylic together and to the saw blade. Just could not get enough cut with this saw, so I moved that blade over onto that Ryobi worm drive. And this allowed me to make this cut, but it still welded all of the acrylic together, and I had to cut them apart with a razor knife. Of course, these have protective plastic coating on both sides that peels off at installation, and that got welded into it as well. I also made the cheap mistake of getting 1/8-inch plexiglass when 1/4-inch would have been better, albeit much more expensive. So on the bottom of each of these Z1 panels, we put flashing on the 2 legs, and then I used a double-sided glazing tape, and if I were to do this again, I would absolutely not use this. I would use silicone caulk, because what I ended up finding was that over time, as the heat affected that acrylic, it warped and bent and gapped away from the glazing tape. So I would definitely do silicone and probably a tighter screw pattern. I used about a 10-inch spacing on these screws, and I would probably go to 6 inches. Of course, because this acrylic is prone to cracking, everything has to be pre-drilled larger than the diameter of your fastener, so that as it heats and cools, it won't press against the metal of the fastener, causing cracks. So here I am drilling through the acrylic, and this is where it cracks right here. Oops. So I had to fix all of those with acrylic cement, and I'm using these neoprene washer roofing screws to attach this. And then on the top side, you only need to flash one side of it because they lap over each other. I also would have spent a little more time considering the overlap of these two flashing sections and done a little trim work on them. Also had some material from boring these holes out that would weld itself to the surface of this, preventing a good seal with the neoprene washer, so I had to scrape all those off. And with that done, it was on to making the windows. The shield style is included in the plans for the Zome, and so I cut up all the legs for the window frames. And then cut out all of the zip panel for the windows and the 4 panels that would have windows. Got all the frames together, and then we were ready to assemble. So I transported all the panels over to the build site, called up the boys, and we got to it. Next panel.
What do you end up insulating these with?
I'm going to use a product called Protex, which is 5 millimeters of closed cell foam with reflective barrier on both sides. Okay. Let's see.
Oh, that's right, because the outdoor. We're lined up here.
Does this do these
Yeah,
get
you
flush?
Yes,
So
right
they're
on
flush
that.
on the inside, the gap on the outside.
Okay.
You can do it so they don't gap on the outside, but then everything's beveled and you got dihedral angles, and
A lot of work.
it's a lot of room to fuck up. All right, you need to tip back just a bit.
Too much?
A little more there.
Well, look over here.
We'll get it after this.
Okay.
When building these Zomes, Johnny has started applying the ice and water shield and shingles wherever possible before assembly, and I think that's really the move. You just roll out your roll of ice and water shield, stick it to the panel, leave about 4 inches proud on the bottom edge with the paper still on it. So you score the paper and peel it off where it's sticking to the panel, and then go ahead and shingle it out, and then once they're assembled like this, you can just peel that paper and lap over the ice and water shield onto the panel below. I think that's the move, and skip all this zip panel
Is
nonsense.
this the right?
Yeah, we're leaning in. Say 4 in it?
No, it's the right 4, but.
Yeah, well, you're gonna.
Oh, because we're leaning in now.
We gotta come to a point at the top.
Right.
That sounded great. It was a big hole gap. Big gap. I'm not an engineer. Stefano's gonna have to push in and over, I think. And then...
Right, that's how we That's why we only do 2 screws.
Yeah, I get it now. And cinch it up. Yeah. I'm surprised the screws can bend like that. Stone.
And of course.
We're almost ready for you to monkey around up here. There's shit to do. I'm here for the fun part.
Look at it, baby!
I can't believe it.
The thing to bear in mind when fabricating all of these panels and doing your assembly is that the precision or lack thereof in your work will be exposed as you start at a 20-foot decagon, but everything must come together to a single point at the top. So any mistakes that you make will just compound and make getting these Z1 panels in place at 13 feet off the ground incredibly tricky. But with a little bit of teamwork and ingenuity, we managed to get everything to come together pretty well. I had never used a zip system when I selected it for the exterior sheathing of this building. I would not use it again. I thought that by taping these seams I would have a waterproof shell, but that was not the case. I did end up coating the upper sections of this with an ice and water peel and stick roll. Now to trim out the windows, I had some cedar I got in a trade with a guy lying in the bushes here, so I selected some of this material that came out of a demolished sauna and got it cleaned up to frame in the inside of the windows. The guy I got this from saw my gate and stopped me one day and said, "Hey, would you make me a gate like that?" And I did, and brought it to deliver and install, and gave him a price, and he haggled me down and said, "I've got this pile of cedar," and so it was a partial trade for this material, which I've used in a lot of projects. So I ripped off the tongues and the grooves and then Made all the appropriate miters for the inside of these windows, and this is actually what the operable portion of the window will rest against. Got everything loaded into the tractor, took it over to the site, and just pin nailed these with 18 gauge brads into the framing. And left them proud of the outside of the building so that any rainwater moving down the building would go around them, and then taped all those edges with ice and water shield, shingled up from the bottom. And then time to build our actual windows. So I assembled the window frames, and then these are getting plexiglass as well. I put a drip flashing all the way around. I had the same problem with this plexiglass using the jigsaw, but at least I was smart enough to pre-drill all of these together. There I am cutting them apart where they've welded together. And then again with the double-sided glazing tape on top of that drip flashing. The other benefit of using silicone in this application is you would have a little leeway in your placement of plexiglass. With the double-sided glazing tape, once you drop it, that's where you are. I'm using the hammer just to pierce the drip flashing with the tip of that screw. And with those complete, I got some single-sided foam tape and put that on the cedar. Window will seal against that. It was just a matter of attaching 2 hinges on the tops of these, and then there will be a 6x6 L flashing that goes on top of these to prevent water from getting anywhere near the window seams. And we've got 4 windows. For the doorway, the plans call for 2 door cards, an awning, and a framing for the actual door. If you were to follow the material list in the plans, this would be a finished grade plywood rather than these zip panel OSB sheets. I ended up having to put some blocking in on the inside face of these so that I could hang those shingles, and made it a little more difficult on myself than it had to be. But with a little bit of fidgeting, this all worked out okay. I also would prefer to have a gabled roof over this entryway rather than the shed awning, because of course it drops all of the precipitation directly in front of the doorway, making a mud puddle. So I'll probably add a gutter to this at some point, or I may put a gabled covered entryway where kids could take their boots off and that sort of thing. But we'll see. there we have our entryway. This allows for a 3-foot door. I drilled some holes in the sill plate here and then drove rebar into the ground to stabilize the bottom portion of that door. Structural screws are required to make this building sound, so I drove 2 from the upper panel to the lower panel on every course and made this building super rigid. The geometry is quite stable, but you just need to make sure that you've got fasteners that can withstand any forces applied to it. And with that done, it's time to put in the earthen floor. We have our sandbox, all of our mason sand. And then I had some subsoil that I brought over from another location on the farm that will screen so that we have the clay necessary for the binder in this floor. To make things easier, I made myself a little platform I could put my screen clay on and then shovel sand and clay into the mixer from one location. I just ran this through a 1/2-inch screen to take out the large rocks and sticks. And then the screen clay goes right there. Gave the road base a good sweep and then wetted it all down. That prevents the earthen floor from drying too quickly and cracking. So once again, Stefano came around and gave me a hand. We're doing a 5-to-1 ratio of sand to clay here, so 15 shovels of sand and 3 of clay, with the addition of chopped straw. So basically sand and clay, and then the water until I get the consistency I want in the mixer. And I went fairly dry with this coat of earthen floor. And a couple handfuls of chopped straw. And as you've seen in my other videos, if you watch them about installing earthen floors, I like to use this rail system where I put a little material on the ground, set the rails on it, and then use a laser and a guide stick that I've marked the height that I want. And the laser hits that mark, and then I can adjust the height of these rails up and down so that they sit in perfect plane, and then I can screed along the top of these rails to end up with a uniformly level, flat floor. So as Stefano is outside mixing material, I can be inside finishing it off. So we get our level with our screed board, and then use the trowel to get the smooth finish that we're looking for. Normally I use a 4-to-1 ratio, and this 5-to-1, though more stable and less likely to crack, did end up being a little dusty, so I put a 1/4-inch final coat on this a little later on. Unfortunately, the leaks through the zip system did some damage to this floor, but I didn't like the ratio anyway, so still needed to do that final coat. And I skirted the whole thing with some leftover roofing and applied these asphalt shingles. I didn't use any tar paper behind them in these lower sections, and as I said before, I did end up using an ice or water shield on the top 2 layers that lapped over all of these. You want to overlap everything at least 2 inches from one panel to the one below it on this. And I started off running these level, and that was a very laborious and time-consuming way to go about it. I did the top 2 sections just running them in grain with the parallelogram, which was much simpler and quicker because then every shingle run is exactly the same length. And so this took quite a bit of time. The overall look in the end, I'm very happy with, however. To button up this top, where these Z1 panels meet, the angle on the ladder is pretty precarious, so I staked down the bottom rung, which made things much more secure. And then I came in and I added glazing tape underneath every lapping flashing piece, got those all screwed down. Working on the outside of the top of the structure is the most difficult part of this build, in my opinion. Then lapped over a couple pieces of flashing at the peak just to keep any rain out of there. And here's that 6x6 L flashing I was talking about over the windows that slipped up underneath the asphalt shingles here. And as I said, I was getting some leaking through the zip tape between these panels. So I'm coming in with expanding foam, and then I went over the top of this with that roll ice and water shield and just covered the whole thing. So I just slit my tape and came in and foamed all these joints and then got them sealed off. Now on the inside, I'm using a Prodex insulation, which is 5 millimeters of close cell foam with aluminum reflective barrier on both sides. And the manufacturer claims this is R17 when installed with this gap behind it. So I established my parallelograms. I was cutting them to size on the table in the beginning and eventually found that if I left them long and then just cut along the seams between my panels, I got a much better fit. And then all of the edges and joints get reflective foil tape, giving you a vapor barrier on the entire inside of this building. So this will act as a parabola. When I put a wood stove in here, it's going to reflect that heat back down onto the earthen floor, which will act as a thermal battery, and we should get pretty stable temperatures in here with just this insulation. Now, if you were building this as an initial domicile on an undeveloped property, you could just use the ice and water shield on the outside and this on the inside, and you would have a waterproof, warm structure for about 2 years before you had to do anything else. I'm sealing the inside paneling material with linseed oil, and I'm using this beetle kill tongue and groove pine. Once all that was sealed, I set up a little shop over at the Zome.
Getting this beetle kill tongue and groove pine installed on top of Prodex insulation. It's pretty straightforward. Once I establish this first pass, I'm aligning all the grain running this direction, and I've graded the timber by coloration as I was oiling it. So I've got things that are almost entirely blue, mostly white, almost all white. And then stacked up here I have all of the bottom sections in almost all blue. And so I just need to lay these out on a table and cut them on the diagonal to get the first course around the bottom of the Zome. I have my compressor, my chop saw, my table saw. I'm going to get set up a little shop over here so we can start rocking these things out.
The effect of this color-graded T&G in this geometrical space is pretty dramatic. Because I couldn't really see my framing members because of the Prodex insulation, I had a few places where I got a little bit off track, and so my joints aren't as tight as I would like them to be, but I have a solution for that. On the farm we have this basket willow that grows along the ditches, and so I'm just going to use some of these willow as trim pieces between my panels. These are about 12 feet high, but the first 4 feet of them is basically branchless and relatively straight. And so basically at every seam I came in and nailed a willow rod. Around the base of the building, I also had to cover up my sill plate and hardware and all that, so I ripped down some plywood and got some pine boards, bullnose, to make this little step all the way around the base.
So today I'm going to do a second coat on this floor. This ratio was 5-to-1 sand to clay. And it just ended up being a little too dusty for my liking. And I had some leaks and things that damaged it in a couple places. So I'm going to come in with a 4-to-1. Instead of straw in the mix, we're going to use cattail fluff.
For this final floor coat, I screened everything down to window screen on both the subsoil clay and the mason sand. You get a very fine finish. And then, as I mentioned there, using cattail fluff in lieu of the chopped straw, which just disappears. So I wet the floor once again and then made this mix pretty thin. And I used a 1/2 by 1/2 notch thin set trowel to try to get my even 1/4 coat and not have to use the laser or any rails or anything like that. Basically just skim coating the surface of this entire floor. Took me about 3 hours working by myself, wasn't too bad. After cleaning up my baseboards, I took some raw linseed oil, which is slower curing but deeper penetrating than boiled linseed oil, and heated it up. And a sweep of this floor while that's heating up, and then always turn off the heat before adding mineral spirits. I went about 25% odorless mineral spirits to the raw linseed oil, and then we're just going to dump this on the floor and squeegee it smooth. I did 2 courses like this with the raw linseed oil, and that took 5 gallons. And so this is going to penetrate through that 1/4 inch finish coat and into the lower coat. As this linseed oil cures, it will polymerize and produce a waterproof, stable finish on and in this floor. There we are after the 2 rounds of raw linseed oil. And then I'm going to come in with just boiled linseed oil, room temperature, no thinner, because it's already got a little thinner in it. And again with the squeegee. All in all, I put 8 gallons of linseed oil into this floor, and it's about 300 square feet. Now for the final coat. Into a gallon of linseed oil, I melted 2 pounds of beeswax. Probably go a little less beeswax in the ratio here. Then we're just going to heat it up until the beeswax melts. Once that's melted, turn off the heat once again, and we'll cut her with 25% mineral spirits. Now, I've never used beeswax as a finished coat on an earthen floor before, and I tried a few methods. This mop, unfortunately, did not give me a very even coat of wax, and also started to peel off a little yellow bits of sponge onto the floor, so we abandoned the mop. Tried the squeegee, which at this point had been worn to almost nothing, and that was leaving the wax a little too thick on the surface of this floor. And then I switched to this 4-inch paint roller, which worked great. This floor only required about a half a gallon of material instead of the gallon I started with. And I applied this, let it dry for about 3 days, and then came back in and buffed it. Here's the look once it's all sealed. So this will be a moppable, waterproof floor. I love this leathery look. For the door, I'm using this 120-year-old Corral pine rail that I salvaged from Stefano's place that I used on the door of his sauna. This is old growth pine, and it's got an amazing patina of lichen and age that I'm going to try to preserve. So the challenge without surfacing all sides of wood like this is getting good references for completely straight flat cuts. And essentially what I do is find the straightest side and then run that against my table saw to cut the opposing side and get something that is reasonably true. my thought was to include a light in this window that is the same geometric proportions as the skylights in the ceiling. So I lay out that parallelogram with the 60-degree angles. And once I got that figured out and cut out of this piece of plexiglass, then I could determine what the other dimensions of the door would be. And so I'm shaving off the worst side of the two on these boards. Just taking a light pass here so I can maintain the bulk of the material. And then over to the planer jointer to take a couple passes and get a very true flat cut on that side. And then I can take that back and on the table saw set my fence at 5 inches and cut the other side, so then I should have two sides that are perfectly parallel to one another that I can do some fairly accurate joinery with. I'm going to use biscuits and glue to assemble this whole door. And had to do it in multiple stages just to get everything to work out. And there is the section for the window in the door. Here you can see the side rails. I left the natural edge on the outsides. Here I'm clipping off a little bit of the extra material from the section around the window to then use to fill in that last little corner. And I left all this stuff proud, glued it up, and got all my biscuits in there and clamped it off. It took several stages to basically put each of these 4 parts together, and a bit of fidgeting and whatnot. So I actually had about 3 days in this door by the time it was all said and done. But the result was certainly worth it. Because I won't be surfacing these boards, I couldn't mark my biscuit location with a pencil. I just used this blue painter's tape. And there's that top panel all put together, and you can see where I'm running wild with the excess on the sides. There's the panel in place where it will be in the door. And it was just a matter of setting up a rail to cut against to get a good straight cut for the final fit. And more biscuit joinery for the bottom panel on the door. Then, to hold the plexiglass window in this door, I took some more of that cedar and set up my 60-degree miter again. And got all these fit into place. I reciprocally framed this opening to match the geometry of the rest of the building. And again, with the glazing tape, peel off the protective film and drop our plexiglass in there. Where I had any gapping in my joinery, I just drafted out some wool and then stuffed that in there with the back side of my utility knife. This blocks light and draft and pretty much fades in in a situation where I couldn't use wood putty. Then I just got a conventional doorknob and hinges, using the template that comes with the doorknob to get the centers on the bore for the knob and the bolt. Two and an eighth hole saw for the knob, and then a 1-inch paddle to bore out for the bolt. Then on those bolts, you have the option of removing the plate and putting in those sleeves, which can then be hammered into the edge of the door. So we went that way. With that done, marked the location of the hinges and scored with my utility knife to then chisel out material to get the hinge to sit flush in the edge of the door. I find this easier than using a router just for that little 16th inch. So this was the material I had around to make the actual door jamb. As you can see, it's wonky and moldy, and my approach was to cut it down pretty close to the final length and then run all this material through a thickness planer to peel off the mildewed sections. Not really to flatten it so much as just to get it cleaned up, and then when I actually hang the door, I can use screws and shims to take any curve and warp out of these boards. Basically just need a sturdy structural frame to hold this door. So I made rabbets in the tops of the legs, chiseled out the waist, and then glued and stapled the top piece to the legs. So essentially I'm just manufacturing what would be the configuration of a pre-hung door. And with that wax dry on the floor, buffed off the excess and smoothed everything out. Got a nice shine on it. I took some of these shingles that I had used inside of the entryway here and snapped them for my shims. Got everything plumbed out correctly. Made sure that my screw would be behind the door stop, visible. And time to hang this door. It's always fun to do by yourself. Pretty heavy too, that one. Got a couple of stickers on the floor to get the height right, so I clear the floor when the door swings in. Notches chiseled out in the door jamb. Like that, we're complete. Here's Barb taking her clients down for some daycare.
What do you think?
Really a beautiful, magical spot down here. Kind of an enchanted forest, so kiddos love it.
Yeah.
This was a fun project and stretched me at times, but I think that for a building that cost less than $5,000, including $2,000 I spent on that wood paneling on the inside. It's a pretty impressive structure. It definitely is architecturally unique and feels like it's twice as big on the inside as it appears to be on the outside. If you're interested in getting plans for this building, there will be a link in the description. And if you have questions, feel free to drop them in the comments, and I will do a follow-up video to answer all of those. And if you like these sorts of builds and permaculture and cooking and all things homesteading, be sure to subscribe to the channel and turn on those notifications to be alerted when I post a new video. And drop a comment. A like always helps. Share it with your friends. And I sure appreciate you guys checking it out.